Hello everyone. In this video, we're gonna learn how to solve a system of two linear equations by elimination. Alright, so in order to solve a system of two linear equations by elimination, we must convert the equation into standard form. Okay, so standard form, which means ax plus by equal to c. So here we have two equations. So I just named the first equation should be a1x plus b1y equal to c1. A2x plus B2y equal to C2. Okay, so let's take a look at the first example. So we have a system 2x plus by equal to 11 and negative 2x plus 5y equal to 13. So the first equation right here, I call this is equation number 1 and this is equation number 2. Alright. So elimination, which means you need to eliminate one of the two variables. So look at this one right here. I see this is 2s. I see this is negative 2s. Right. So what if I'm going to add these two equations up? Okay. So what happens? If I add 2s and minus 2s, this guy should be 0. Right. Now 3y plus 5y, this should be 8y. And 11 plus 13 should be 24. Alright, so I just literally eliminate the variable s, right? Now I'm going to divide both sides by 8. So I have y equal to 3. Alright, I box this one. This is my answer for the y value. Now I need to substitute y back into one of these equations right here. You can substitute into the second equation or the first equation. You still get the same answer. So I'm going to substitute y equal 3 into the first equation right here. So basically I substitute 3 for y, right? So I have 2s, I rewrite 2s plus 3 times, right? Y, but y equal to 3. So I have 3 right here. Equal to 11. Alright. Now, I'm going to solve for s. So I have 2s plus 3 times 3 equal to 9. Equal to 11. Alright. I subtract 9 both sides. So I'm going to end up with 2s equal to 2. Alright. So I'm going to divide both sides by 2. Alright. So s should be equal to 1. So this is my solution for s value. And this is solution for y value. Now you need to conclude that the system has a solution 1, 3. When you write a solution to the system of equations, you need to write s first and then y second, right? S comma y, s equal to 1, y equal to 3. So you need to write 1 comma 3, alright? Now let's move on to the example number 2. So we have 4s plus 3y equal to 2 and 5s plus 3y equal to negative 2. Alright, so back to the first example right here. We just eliminated the variable s. Alright, now the second example right here. We look at this one right here. We see that, right, the coefficient of s right here different. But the coefficient of y are the same, right? So we need to eliminate the variable y. Okay, so what should we do? We see that this is 3y, this is 3y. So what if we do subtraction? Alright, so we take the first equation, we subtract the second equation to see what happens, right? So 4s subtract 5s, we end up with negative s. Alright, 3y subtract 3y is going to be 0, right? So it could be 0 equal to 2 subtract negative 2, right? So we need to write 2 subtract parenthesis negative 2, all right? It's the same thing as 2 plus 2, and it's going to be 4. So we put 4 right here, okay? So negative s plus 0 is going to be negative s equal to 4. Now we need to solve for s. So we need to divide both sides by negative 1, right? Divide this guy by negative 1, divide this guy by negative 1. Alright, so negative side and negative side right here cancel out, right? So s divided by 1 should be s equal to 4 divided by negative 1 should be negative 4. Alright, so if you don't understand this one, use the triangle trick right here. You have the plus side right here, negative side, negative side. Alright, so this is the trick. Now you see that 2 negative side right here, you cover this one. Alright, the answer should be positive. That's why we got positive s. Alright. Next one, look at the right hand side right here. This is 4 right here, positive, right? So we cover this one. Negative right here, we cover this one. The answer should be negative right here. So that's why we get negative 4, right? So this is solution for the s value. Now, after you get the s value, you just substitute s equal to negative 4 into one of these equations. You still get the same answer. So I'm going to substitute negative 4 for s into the first equation right here. Alright, so I'm going to have 4 times s, but s equal to negative 4. So I put negative 4 right here. Alright, plus 3y equal to 2. Alright, now I'm going to solve for y. So 4 times negative 4 should be negative 16 plus 3y equal to 2. Now, I'm going to add 16 both sides. So I have 3y equal to 18, right? This guy cancel out. Now I divide both sides by 3. So this guy cancel out. I have y equal to 6, right? So the system has a solution negative 4, 6. Now let's move on to the next example, example number 3 right here. So we have ax minus 4y equal to negative 4. 4y equal to 3x plus 14. Alright, so you see that in order to solve a system of two linear equations by elimination method, okay, your system must be in standard form. Now you look at the first one, this is standard form, but the second equation right here is not in the standard form. So you need to convert the second equation into the standard form. So I just rewrite the first equation, ax minus 4y equal to negative 4. Now the second equation right here, I subtract 3s both sides, right? If I subtract 3s both sides, I'm going to end up with negative 3s plus 4y equal to 14, right? Okay, so now your system already in the standard form. So you just use elimination method to solve it, okay? So you observe that negative 4y and 4y right here, they are opposites. So you're going to add this guy up, all right, in order to eliminate the variable y, all right? So as plus negative 3y should be 5s. Negative 4y plus 4y, it should be 0, right? So I don't need to write 0. Equal to negative 4 plus 14 should be 10. Alright, now I divide both sides by 5. Alright, 5 and 5 right here cancel out. So I have s equal to 2. Alright, I box this one. Now I need to substitute s equal to into the first equation or the second equation, right? So I substitute s equal to into the second equation because it's already in the slope-intercept form, so it's easier, right? So I have 4y, I rewrite 4y equal to 3 times s, but s equal 2, so I multiply by 2, right? Plus 14. Alright, so I just simplify this one, so it could be 4y equal to 6 plus 14. Now 4y equal to 6 plus 14 equal to 20. Now I need to divide both sides by 4. So y equal to 5. Alright, so now you need to conclude that the system has one solution to 5. Now let's move on to example number 5. So we have 6x plus 5y equal to 19. 2x plus 3y equals 5. Right? Okay, so we look at the coefficient in front of x right here. We see that they are different. Coefficient in front of the y variable right here, they are still different. So, because they are different, you cannot add or subtract to make them 0, right? So you need to manipulate something to get them equal before you're gonna add or subtract, right? So I look at the first variable right here, the variable of x right here. I see this is it. So if I multiply both sides of the second equation by -3, I get the opposite value right here. It should be 6 and -6, right? Alright, so I need to rewrite the first equation. 6x plus 5y equal to 19. Now, the second equation right here, I just multiply both sides by -3, right? -3 right here. So I have -3 times 2s should be -6s. -3 times 3y should be -9y. Equal to -3 times 5 should be -15. Alright. Now I look at this one right here. I see that this guy opposites. So I just add them up to make them 0. Right? That's called elimination. Alright, so 6s plus -6s should be 0. 5y plus -9y should be -4y. 19 plus -15 should be 4. Alright? So, I'm going to divide both sides by -4. Right? So this one and this one cancel out. So I have y equal to -1. I box this one. Alright? So I need to substitute this guy into one of this equation right here. Right? I substitute -1 for y into the first equation right here. Alright? So I have 6s plus 5 times y, but y equal to -1, so I put -1 right here, equal to 19. Alright, so it could be 6s minus 5 equal to 19. Alright, now I need to add 5 both sides. So it could be 6s plus 24. Right, I need to divide both sides by 6. Right, so s equal to 4. Alright, so the system has a solution for -1. Now let's move on to the example number 6. So we have 4x plus 5y equal to 35 and 2y equal to 3x minus 9. Alright, so this example is similar to the example number 3 right here. We need to rearrange this one first. Alright, So in order to rearrange this one, I need to convert the second equation into the standard form, right? So what should I have? I rewrite the first equation. 4x plus 5y equal to 35. And the second equation should be, I need to subtract 3s both sides, right? So I have negative 3s right here. So I have negative 3s plus 2y equals to negative 9, right? Now I look at the coefficient in front of s right here. This is 4, this is negative 3. And coefficient in front of y right here should be 5 and 2 right here. So these coefficients are different, right? I need to make them the same so that I need to add or subtract to eliminate one of the variables, right? So I look at the first variable right here. Okay, I see this is coefficient is 4 and negative 3 right here. Now I need to find the least common multiple of 4 and 3. So the least common multiple of 4 and 3 should be 12, right? Okay, so 12 divided by 4 equal 3. So the first equation right here, I need to multiply both sides by 3. And the second equation right here, I need to multiply both sides by 4, right? So that I get 12, right? 12 right here. Okay, so it's going to be 3 times 4 is going to be 12s. 3 times 5 is going to be 15y. 3 times 35 it should be 105. Now 4 times negative 3s should be negative 12s. 4 times 2y should be 8y. 8y. 4 times negative 9 should be negative 36. Alright, now I observe that the coefficient in front of s variable right here opposites, so I need to add them up to make them 0, right? So 12s plus negative 12s, this guy cancel out, so it should be 0 right here. 15y plus 8y should be 23y equal to 105 plus negative 36, it should be 69. Alright, now I need to divide both sides by 23. So I'm going to end up with this guy cancel out. Y equal to 3. So I block this one. Alright, now I need to substitute y equal 3 into one of these equation right here. Alright, so I'm going to substitute y equal 3 into the second equation right here. So I'm going to have 2 times y, but y equal to 3, so I put 3 right here. Equal to 3s minus 9. So I need to solve for s. So 2 times 3 equal to 6, equal to 3s minus 9. Alright, so I just rewrite this one as 3s minus 9 equal to 6. I'm going to add 9 both sides. Alright, so this one and this one cancel out. So I have 3s equal to 15. Now I divide both sides by 3. So s equal to 5. And the system has 5, 3. Now let's move on to the example number 8. We need to find the number of solutions to this system of equations right here. So we have 2s plus 6y equal to 18 and s plus 3y equal to 9. Alright. Now observe that the coefficient in front of s right here different and coefficient in front of y right here different. So we need to make them the same, right? So in order to make them the same, I need to multiply the second equation by 2, right? So I multiply this guy by 2. So what do I have? I have the first equation I need to rewrite. So 2x plus 6y equal to 18. Now the second equation, 2 times x could be 2x. 2 times 3y should be plus 6y. 2 times 9 should be 18. Alright. Now you see that the second equation right now is going to be identical to the first equation right here. Right? So let's see what happens. I need to do subtraction. Right? So I have 2x subtract 2x. It could be 0. Plus 6y subtract 6y is going to be 0. Equal to 18 subtract 18 is going to be 0. So the left hand side should be 0. The right hand side should be 0. Alright, so if the left and the right hand side the same, the system has infinitely many solutions. Consider the next example. 3x plus 9y equals 15. X plus 3y equals 27. Now we observe that the coefficient in front of the variable x and y are different. So we need to make them the same. So we see that this is 3. We need to multiply the second equation both sides by 3. Right? So I need to rewrite the first equation. So right, it's going to be 3x plus 9y equal to 15. And the second equation, 3 times x should be 3x. 3 times 3y should be 9y. And 3 times 27 should be 81. Alright, so since they have the same coefficient right here, I need to do subtraction to eliminate the variable x. Alright, so 3x minus 3x is going to be 0. 9y minus 9y should be 0. Equal to 15 minus 81 should be negative 66. 0 plus 0 should be 0. Then this one should be negative 66. Now 0 equals negative 66. This is impossible. So the system has no solution. Let's move on to the last example. So we have 4 over y plus 5 over z equal to 17 and 2 over y plus 3 over z equals 10. Alright, so we need to use the chain available because y 0 here in the denominator. So we let a be 1 over y, b be 1 over z. Alright, so this one right here we just rewrite, we will see it. This one equivalent to 4 times 1 over y, right? Plus 5 times 1 over z equals 17. And the second equation should be 2 times 1 over y plus 3 times 1 over z equal to 10, right? Now, I just substitute a for 1 over y and b for 1 over z, right? So I have the new system. Alright, so I have 4 times 1 over y should be a, right? So for a plus 5, 1 over z should be b, so 5b equals 17. Now the second equation should be 2a plus 3b equals 10. Alright? Alright, so now I'm going to solve this system normally, right? So I look at the coefficient right here. This is 4, this is 2, right? So I multiply both sides of the second equation by 2, right? So what should I have? I rewrite the first equation. So I have 4a plus 5b equals 17. Now the second equation, 2 times 2a should be 4a. 2 times 3b should be 6b. 2 times 10 should be 20. Alright, so I look at the coefficient right here, they are the same. I need to do subtraction. If they are different, if they are opposites, you need to do addition, right? So 4a subtract 4a gone. 5b subtract 6b should be negative b equals 17 subtract 20 should be negative 3. Alright, so I need to divide both sides by negative 1. So it turns out to be b equal to 3. Alright, so b equal to 3, I need to substitute back into the first equation right here, right, to solve for a. So I'm going to have 4a plus 5 times b, but b equal to 3. So put 3 right here. Equals 17. Now I need to solve for a. So I have 4a plus 15 equals 17. I need to subtract 15 both sides. So I have 4a. This one cancel out. Equals 2. Now I need to divide both sides by 4. So a equals 1/2, right? Box this one. Right, this is not the final answer. The final answer must be y and z. So I have b equal to 3, but b equal to 1 over z. So I substitute 3 for b into this one right here. Right? So I have 3 equals 1 over z. Right? Now, 3 right here, I can rewrite 3 as 3 over 1. Right? In order to solve for z, I need to flip this one, right? 1 over z turn out to be z over 1, so I just write z. Now, 3 over 1 turn out to be 1 over 3, so it should be 1 over 3 right here. So z equal to 1 over 3. This is my answer. Now the second equation right here, a equals 1/2, right? But a equal to 1 over y right here, okay? So I substitute 1/2 for a into this one, right? So I have 1/2 equals 1 over y. Alright, now in order to solve for y, I just flip this one. So 1 over y turns out to be y over 1. So I just write y, right? Now, if I flip this one, I need to flip this one. So 1/2 turns out to be 2 over 1, should be 2. And this is my solution. So finally, the system has solutions, right? You need to write y first, z second, right? So y should be 2. So 2, 1 third. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young, it has just begun as she puts her hand in mine.